Today we're going to be talking about the law of sines and the law of cosines and when to use which law. So let's go straight to number one right here. I want all of you to highlight or put a box around right here. Hopefully you're getting good at recognizing this. Notice how you have a pair. Anytime you have a pair, you're going to need the law of sines. That's a huge indicator that that's the law we want. Notice how we only want to find x here. So there's no need to find everything in the triangle for a question like this, and that's true for an exam as well. I'll often put questions like that on an exam just because I've tested you for finding everything already. So for exam questions, I sometimes might ask questions like, what is this angle? Or what is this particular length? So let's go straight to finding that angle there. So let's write our pair. Notice how the angle's on top because we're trying to find an angle. So I'm going to write sine of 125 degrees over 25 is sine x over 12. If you're comfortable, I'll let you skip to this step in your work now. X should be the sine inverse of 12 sine 112 all divided by 25. That you plug that in your calculator and you're going to get 26.4 degrees. So don't forget your degree symbol. That's number one. Now number two, a couple of things to notice here. This is a side angle side triangle, or sometimes I call it an angle sandwich. But some people just use the idea that there is no pair. All of those things are good, and those all indicate you're going to need the law of cosines. We just want to find x, so let's use our law. We learned last class that x squared should equal 16 squared plus 15 squared minus 2 times 16 times 15 cosine of 87 degrees. And again, notice how the corresponding length and angle, that's always going to be right here. So for law of cosines, hopefully you recall that from our last lesson, that this length and this angle are always going to match. Now, a few of you last class asked if you can just skip to this part. X equals square root of 16 squared plus 15 squared minus 2 times 16 times 15 cosine 87. And yes, that would be fine for work. I'll know what you're doing. So you plug that into your calculator and you get 21.35. Since there are no units on these particular problems, we won't write any units on this. Number three, notice how this is a side-side-side triangle, or you can notice there are no angles. So clearly there can't be any pair here. So that's going to indicate we do need the law of cosines. Let's highlight the angle we want to find, and let's indicate the corresponding leg. So that's going to mean 30 squared is equal to 55 squared plus 37 squared minus 2 times 55 times 37 cosine of the angle x. Now, if you're comfortable, again, you can skip straight to here. X must equal cosine inverse of this entire expression. If you do the algebra in your head, 30 squared minus 55 squared minus 37 squared divided by negative 2 times 55 times 37. You don't have to do that, but I know a couple of you are getting really good at this in your head, so you can just write that step. You plug that in your calculator, and you're going to get x is equal to 30.9 degrees. And again, don't forget that degree symbol. Let's go to our last example for this first part. Hopefully you can recognize there is a pair right here, which means we need the law of sines. A little bit different from last time. If we're trying to find x, that's a length. So if I write x over sine 100, we need to put the length on top. 56 over sine 42. Let's multiply by sine 100. So x must equal 56 sine 100, all divided by sine 42. You plug that in your calculator, and you get 82.42. This is the final part of the video. I need you to skip to number 9. This is going to be page 2. So this part is meant to be done with no calculator. On your test, you will have a calculator, but you're going to be asked to do it in this particular method. So even having a calculator wouldn't really help you here, because it's more about understanding the method that it simply doesn't require a calculator. So notice how it says SSA. This is called the ambiguous case, and normally we use law of sines. I'm going to show you how to do this without the law of sines. And the goal here is this: how many triangles are possible given the measurements? Now that would mean our answer, so I'll write a big note here, our answer is going to be 0 triangles, 1 triangle, or 2 triangles. So for all of these, that will be your final answer. You're actually not solving. You're just trying to figure out how many triangles are actually possible. So let's go straight into it. So I'm just going to draw a triangle right here, generically. The exact same way I've been labeling everything, A, B, C. This is kind of why. So I'm going to put A, B, C, put 2 right here, 10 right here, and 30. And I do recommend drawing it the exact way I draw it on my iPad right now. What we're going to do is actually drop a height right here. So imagine you drop in this blue height, call that H. Now we're going to use basic trig, so not going to use law of sines here. Let's just imagine you're standing right here, and let's use SOHCAHTOA. Sine of 30, that is equal to H over 10. And let's solve for H. We actually know what sine 30 is, that's 1/2. So 1/2 is equal to H over 10. Let's multiply by 10. So H is equal to 5. So that would mean this leg right there is 5. Now notice that this leg right here is 2. So if I were to kind of make this more to scale, the 2 would be something like this, about that long, if this were actually the length of 10. So notice how this is 10, this is about a fifth, that's 2. This height right here is actually 5. So if I were to fill that in, again right here, this leg is 5. So really think about this. How many triangles are possible? 0 triangles, 1 triangle, or 2 triangles? The answer, 0 triangles. Now the reason for that is because look at this leg right here. It's 2. There's no possible way that this leg can ever reach down there. It's way too short, especially if this height right here is 5. Which means this 5, this height we found, represents the minimum length of A. So the way you actually write your answer is this. I'll put a box for you. This is how we're going to mathematically state our answer. A is less than H, so that length of A of the triangle is smaller than H. Therefore, there are 0 triangles. And that's it. So again, that's our goal. So that's number 1, or number 9, I should say. Let's go to the next one. Let's draw generically again. A, B, C. This is 5, this is 10, this is 30. Step number 1 is always drawing the height. Okay, that's always step number 1. So number 1, we're going to find H. Same step. Sine 30 equals h over 10. We know sine 30 is a half, so this should look pretty familiar. Let's solve. H is 5. Now let's compare that. 5 and 5. They're the same. So let's write that. A is equal to h, which means if I were to redraw this triangle, it actually looks like that. This is 5. It means that actually is a triangle we drew right there, which means how many triangles do you think there are? 1. The one we actually drew right there. There it is. There's our answer. That's how many triangles are possible with the measurements that are given. Okay, let's try 2 more. So once again, notice how I use 30 a lot? That's because this is meant to be done with no calculator. So 30 is a really nice angle to work with. So here's our A, B, C, 10, and 8. Okay, so first step, let's try it. Draw in the height. There's our right angle, H. Sine of 30 equals H over 8. That's 1/2 equals H over 8. H should equal 4. Now let's compare A and H. 10 and 4. So we're going to write A is greater than H. So this is the first time this has happened. What does that mean if it's greater? So essentially what's happening is, at this point we can conclude this. There is at least one triangle. We know that because 8 and 10, there's nothing really wrong there, and H is the minimum, so 10 is clearly more than the minimum, so we're good. Now the second triangle happens if we were to swing this leg in, like that. Does it fit in the triangle? And does it fit here? No, it does not fit. You can see that this thing is breaking the plane. So what you do is you write A is greater than B. Therefore, there's only one triangle. So the only way that the second triangle can exist is if when we swing this leg in, it'll actually stay in the triangle. But this one, if we swing it in, we can see it can't fit. So I'll kind of show you how that works the next time. So I'll leave my picture like that. So again, we're focusing on that part. Now here's the last one. So we're expecting 2 triangles here, so let's really see how that works. A, B, C. A is 6. This is 9. 30. Let's drop the height in. So again, step number 1, find the height. Sine 30 is H over 9, so 1/2 is equal to H over 9. H is 4.5. So clearly I can write A is bigger than H. So A is greater, therefore we know there is at least one triangle at this point. Now if 6 is less than 9, what's happening here is, if you imagine this, I'll try to draw it a little more to scale now. It's saying that if this were to swing in, this thing, it would actually fit like that. Which means there are actually 2 triangles possible, because A is less than B, meaning this leg right here has the ability to swing in like this. So there's one triangle right there, and then there's a second triangle right there. So that's what that means when we're doing like the 2 triangles possible, 1 triangle, 0 triangles. That's kind of the concept behind it. So if A is bigger than H and A is less than B, right, therefore there are 2 triangles.